Morning all, as you can see the question in the thumbnail. So part A of the question was if a function f is defined from R to R such that f of x equals minus x for all x belonging to R, we call this kind of function as funny function. So first part was to prove there exists at least one funny function. That's not very hard. We can design a function. Let's say f of x is 0 at x equals 0, x plus 1 for x greater than 0, and we can use the smallest integer function to be odd. What is the smallest integer function? It's a function, basically let's say smallest integer of 0.5 will be 1. So it's greatest integer plus 1. Similarly, we have minus x plus 1 for x greater than 0, and a smallest integer is even. And we have x minus 1 if x less than 0, and greatest x is odd. So the last one is greatest function. So if you consider this function, you can clearly check f of x equals minus x. So there exists at least one funny function. The second part was more interesting, and it was to show like there is no funny function that is continuous. As you can see in the first part, this is a discontinuous function. So in order to obtain a contradiction, suppose that f R to R is a funny function that's continuous. So the first observation that we can see is, let's say f of a equals f of b. This implies composing f on both sides, f of a is f of b, and according to the functional definition, it follows that a equal to b. So interestingly, we have shown that this funny function must be an injective one, right? Now we can substitute f of a for x in the functional equation. That gives f of a is going to be minus f of a. However, the function equation also implies if you replace composition of f on both sides, this also implies f of minus a. So from these two observations, we expect f of minus a equals minus f of a for all a belonging to real, and that shows the function is an odd function as well. So we have an injective and odd function, right? So f is an odd function, and clearly if I keep a equals 0, f0 is minus f of 0, and that forces f0 to be 0. So we know it's an injective and odd function. Now suppose if f of 1 is, let's say, positive, because now we know function can behave in many ways, and one of the way of behaving is this injective 1 1 and odd, symmetric or odd. Just one of the sample. So let's say at f of 1 we are getting some positive value, right? Then the fact that f is continuous and injective implies that f of a is greater than 0 for all a greater than 0, right? If f of a becomes positive, and we know the function is continuous and injective because I have assumed the function to be continuous, then definitely existence of f of 1 greater than 0 will implies for all a greater than 0, f of a must be positive. 0 for which f of a is less than 0. Suppose there is some a for which f of a less than 0, if you feel so. This combined with intermediate value theorem would imply existence of b greater than 0 for which f of b is equal to 0. And that is clearly not possible because the function is injective, and we already know that f0 is 0, so it cannot be at any other value apart from 0, right? So suppose if f of 1 is greater than 0, now we deduce f of 1 is greater than 0, which contradicts the fact that f of 1 is minus 1, as you can clearly see in the given expression. F of x is minus 1. So that's just a contradiction. Similarly, if f of 1 is less than 0, we'll get same contradiction. The fact that f is continuous and injective implies f of a is less than 0 for all a greater than 0. Okay, and that f of a greater than 0 for all a less than 0. So we again deduce that f of 1 is greater than 0, which is again a contradiction because f of 1 is clearly minus 1. Right? So from both of these, we can conclude like there is no continuous function such that f of x is minus x for all x. Hence, the second statement is also established. Now, of course, you could have approached the problem in many ways. More generally, you can construct solutions to the function equation in this way also. Let's say if you partition the positive real number into two sets A union B, such that there exists a bijection between maybe G A to B, and if we define A bar is minus A such that A belongs to A, and B bar is minus B such that B belongs to B, तो आप ऐसे भी डिफाइन कर सकते थे. लेट्स से एफ ऑफ एक्स इफ आई डिफाइन 0 फॉर एक्स इक्वल टू 0, जी ऑफ एक्स इफ एक्स बिलोंग्स टू ए माइनस जी ऑफ माइनस एक्स इफ एक्स बिलोंग्स टू ए बार माइनस जी ऑफ एक्स इफ एक्स बिलोंग्स टू बी and g of minus x if x belongs to b bar. So you can clearly check f of x equals minus x will also happen for this f of x equals minus x independent of what g function I have selected. It's true for all solutions as a wave function. So it was a good problem, and take away from the problem was sometimes in the problem statement of JEE and CMI or ISI you have to start with proof by contradiction. I hope you must have enjoyed the question and understood how we contradict this. Moreover, from this functional relation, see how we have obtained the idea that it is an odd function. Moreover, it is an injective function. Okay, since it's injective from R to R, and we have also shown like it's an odd function, so these two important observations can be directly asked.